Welcome back. So I've got quite a challenging do now for you for the start of this lesson. Probably not a very good idea to challenge you guys so close to the end of term, but hopefully you're still working in the same book that you've been working in since the beginning of the course. So you can look back to last week's lesson and have a look and see what we were doing. So this is a bit of a challenge. I want you to find the equation of the straight line through P. Okay, oh, sorry, and what I should have said here, it needs to be in the form y equals mx plus c. So let me just add that in. Okay, there we go. Okay, so there's your do now. Hello, Zayan, welcome back. You can get started on the do now, even if you can't do it. Just at least try and calculate the gradient of the line at the very least. Who else is with us? Our usuals. Hello, Sihle. Hello, Nizole. Hello, Snare. And Katlejo. And Nawazi. Hello. Yeah, you weren't there on Thursday. I know, Katlejo. We missed you. Shame you missed the last lesson. So this is the do now is going to be a bit difficult for you, Katlejo, because you weren't here the last time. So I tell you what, Katlejo, because you weren't here, your challenge is going to be to calculate the gradient of this line. Okay, so I want you, everybody else will be able to do a little bit more, but because you weren't here, what I want you to do is calculate the gradient of line PQ. Okay, Katlejo? No problem. Yeah, we missed not having you here last time either. Everybody was so quiet last time. So I don't know if everybody's going to be super quiet again today. I think everybody's energy levels are just right down in the pits. I'm good, thanks, David. How are you? Okay, and then there is gradient formula. That's a nice message. Thanks, Nolwazi. Okay, so there, you try that one in blue, okay, Katlejo? Yeah. Everybody else that was here last week, let's see if you can do what we spoke about the last time, okay, which was to find the equation of a straight line in the form y equals mx plus c. Hi, Harry. Okay, I hope I've said hello to everybody. Hello, Jared. I didn't say hello to you. Hello, Kelebohile. Hello to Tuka. Welcome back. You're just going to try and work out the equation of line PQ, if you can, in the form y equals mx plus c, like we were doing last time. If you can't do the whole thing, it's also not the end of the world. Oh, well done, Harry. Can you at least just work out the gradient of the line using gradient formula? Hello, Zayan. I don't know if I said hello to you either. Okay. Oh, it's nice to have everybody back together again. I always look forward to our lessons, and I know I'm going to be with you guys. Okay, so Harry, just hang tight. Let's just see where everybody else is. All right. How's it going, guys? Okay, so have I given you enough time, grade 10s? No one else has put anything in the chat, so I just wanted to get an idea of where you're at with this. Harry says he's done. Is anybody else finished? Okay, so then I'll take your silence to mean no, you're not finished yet. You want me to give you just a little while? You're done finding the gradient. Okay, David. All right, I'm sorry. Let me be quiet and I'll give you guys another few minutes. I beg your pardon. Okay, so we're 10 minutes in. I'm sorry to interrupt you, but I'm going to have to ask you to stop where you are And let's just talk about how we would do this before we can move on. I know that this was a difficult question, all right? I specifically made it difficult just to see, so that you could actually get an idea and so that I can get an idea as well of how well did you understand our previous lesson? Have you been able to apply those skills again now, all right? And I'm hoping, although the only person who's told me they finished is Harry, I know that David says he's finished finding the gradient. I'm hoping that at least all of you would be able to find the gradient. Okay, so in that case, David, can you tell me what did you get the gradient to be? What was your gradient? David, can you hear me? Did you manage to work out a gradient, David? Okay, so Harry, what was your gradient?
I got 3/2.
3/2, says Harry. Okay, so Harry says the gradient was 3/2. And what did you work out the value of C to be, Harry?
-7/2.
-7/2. All right, so tell you what, let's compare that with my answer and let's see how we got on. So this is mine here behind the pink. Ha, look at that, Harry. We got the same answer. Okay, so I also got 3/2 for my gradient, and I also got -7/2 for my y-intercept. Okay, so Harry, that's really well done. And I'm so pleased that you were able to do this from last week. That's really, really great progress. All right, so good job, Harry. Very, very nice. Let's give you some clapping hands. I think you definitely deserve them. That was a seriously tough question. All right. I know you would be, Katlejo. Don't stress. Okay, hopefully you're going to be able to catch up this lesson, but it's going to be a little bit difficult for you. All right, everybody else that was here last week, okay, how's it going with you? Did you manage to work out the gradient? Shame, guys, you were quiet last week and you're even quieter this week. Did anybody manage to calculate the gradient? Do I need to explain how Harry and I got a gradient of 3/2? Okay, so Ria Betsva says, yes, ma'am, you also got 3/2. That's great, Ria Betsva. Well done. Zayan, you also got the gradient. Good job. Very nice. Okay, so Mohamwalepe says, please explain. That's fine, not a problem. David, me too. All right. Okay, so Mohamwalepe and Katlejo and anybody else who wasn't able to get the gradient, let's just go and have a look over here. All right. We have 2 points, grade 10s. We have point P, which has the coordinates -1 and -5. And we have Q. Oopsie, I shouldn't put the equal sign there. And that has the coordinates, let's just double check here, 5 and 4. So if you recall, I had said to Mohamalepe, I want you to start off by doing what? What's the first thing I said would be a good idea? You need to You need to number your coordinates, okay? So if you're going to make this one x1, you've got to make that one y1. You've got to make this one x2 and that one y2. That's your starting point, okay? You have to write that down and you have to learn that. The next thing you're going to do is write down your formula. And now substituting into your formula is going to be super easy because you've already labeled what goes where. So in the place of y2, Katlego, what should I write? In the place of y2, what should I write, Katlego? Indeed, 4, good. And then I've got to write the minus, okay, like the minus inside here, I've got to write the minus. And then in place of y1, what should I write? I have to write minus 5. Okay, then at the bottom, if I started at 4, I started with y2, then I have to start with x2 at the bottom. So x2 is 5. So I'm going to put 5 at the bottom, minus, and that also happens to be a negative number. All right, and now I can use my calculator. 4 minus negative 5 is going to be 4 plus 5, which leaves me with 9. 5 plus 1 is going to leave me with 6. Both of those numbers are in the 3 times table. And if you did this on your calculator would go straight away to finding out the answer is 3/2. Okay, so everybody should have been able to do that. All right, at the very, very least, you should have been able to work out the gradient from a pair of coordinates. Okay, then this is the hard part. Okay, now working out the equation of the line. Can anybody tell me where this 3/2 needs to go? Where should I be writing it?
In the place of m.
In the place of m, quite right, David. So I'm going to say y equals 3/2 x plus c. And now I want to sub in one of my points. Either I'm going to sub in P or I'm going to sub in Q. It doesn't matter. I will get the same answer either way. So if I was you, make your life easy and sub in a point where you don't have to work with negatives. All right, so I would choose Q in this instance. So I can see that the y coordinate at Q is 4. So in place of y, I'm going to write 4, 3/2, and in place of x, I'm going to write 5. Okay, and then the calculator can do this for me, all right? If we ask the calculator to work out 3/2 times 5, our calculator is going to tell us that the answer is 15/2. Next step, we have to take that 15/2 over to the other side. Okay, so when I take a term over to the other side, grade 10s, I have to remember to subtract, got to change the sign. And again, your calculator can work this out for you. You don't have to do it. And you'll see when it does, your calculator tells you that the answer is minus 7/2. All right, so final answer here. Y equals m 3/2 x plus c, so that's minus 7/2. Okay, so that's how it needed to be done. Does that feel a little bit better? Are there any questions? No questions. Okay. All right, so let's go and talk about parallel and perpendicular lines. I don't know if we're going to get to perpendicular. Good, Zayon, I'm glad. All right. Let's talk about parallel lines and let's talk about perpendicular lines. Okay, so when we say the two lines are parallel to one another, they are specifically telling you, grade 10, that they have equal gradients. So that is something that you need to take note of, all right? So maybe in your books you can write this down. The word parallel, and they tell you lines are parallel, it specifically means that gradients are equal. So if you know the gradient of one line, and you've been told that that line is parallel to a second line, you know the gradient of that second line as well. Okay, so if we have a look at this example over here, we've been told that the blue line, the blue dashed line, takes the form y equals minus x plus 4.5. What value is the gradient of the blue line? Which number here tells me the gradient of the blue line? Can anyone tell me?
Number 5.
Unfortunately not. Which letter in y equals mx plus c represents gradient? The M, exactly, Nizole. Okay. So now compare what you see here in blue to what I've written in orange. Okay. What's in front of the X here? Yes, perfect, Nizole, 100%. So the gradient, perfect. The gradient is -1. M is equal to -1. That's what they're telling us. Okay, perfect. So these two lines are parallel to one another. The gradient of the blue dashed line is -1. That means that the gradient of line AB is also going to be -1. So if we now want to work out the equation of line AB, this is what we're going to do. We see that they've used the word parallel. When we see that lines are parallel, we know that their gradients are equal. So the gradient of the one is the same as the gradient of the other. So straight away, what I can do when I want to work out the equation of line AB, I can say the gradient is also -1. But I don't know what the y-intercept is. And that's why I have to have this point over here. There's my x and there's my y. Okay, my x, just in case this is a little bit difficult to see. All right, so the point A is the point -1, and then your x-intercept is 2.5. Okay, so you can also write that as 5/2 if you want to. This is the x and y pair that we now need to sub into our equation. All right, so where am I going to put the 2.5? In place of the which letter?
In the place of the y.
In the place of the y, David, 100%. So I'm going to write that, yes, Harry, in place of the y. So are you okay, grade 10s? I'm going to write it as 5/2. 2.5 is the same as 5/2. Is everybody happy with that? Then in place of the x, I'm going to write -1. Okay, so now somebody other than Harry, okay, not anything against you, Harry, but I'm sure you'll be able to work this out if you could do the other one. Somebody apart from Harry, can you please tell me what you get for C? What's your C value? You can use your calculator, it doesn't matter. What's C going to be equal to here, grade 10s? Kelebogile, what did you get for C? Kelebogile, I don't know if you can hear me. What did you get as your answer for C? Okay, let's see if somebody else can maybe tell us. Oh, there we go. Oh, sorry, guys. I wasn't looking in here. Okay, so Nzole said, you don't know if it's right, but you got 3/2. Good. Mohamalepe said you got 3/2. Maya said 3/2. Harry said 3/2. And guess what, guys? You are 100% right. It is 3/2. There we go. Well done. Okay, the answer is 3/2. Good, David. Perfect. Okay, so that means that the equation of line AB, it is the line y equals minus 1x. Remember, I don't have to write the 1. Okay, plus 3/2. How does that feel, grade 10s? Thumbs up, thumbs down, smiley face, not smiley face. Shame, you guys are so quiet tonight. Okay, thanks, Harry. Everybody else? Okay, see, they're good. Thanks, David. So. Okay, Riabetswe, it's fine. It's always difficult when we learn how to do new things. Okay, so now I want to give you guys an opportunity to practice this. Okay. There we go. All right. So again, you are told that the blue line is the line y equals x minus 5. I would like you to find the equation of line AB if it is parallel to the line y equals x minus 5. Okay, so I'm going to give you 5 minutes and then you guys try that question. Okay, so everybody else ignore me, and Katlego and David, I want you guys to listen to what I'm saying, okay? So Katlego, based on the conversation that we've had so far, I know David's offered some answers tonight, so that's why I'm asking you. Can you tell me the blue line that's currently on the screen, can you tell me what value is the gradient? What's the number in front of the x? Do you know what the number is in front of the x? Okay, maybe, you know what, Katlego, sometimes things are so easy that they're difficult, right? So if I write a letter, David, you're saying minus 2, unfortunately not. Okay, so here's the blue line. It is the line y equals x minus 5. It has been written in the form y equals mx plus c. So they are implying that the value of m is 1. Okay, there's an invisible 1 standing in front of the x. Okay, so if they tell you that the equation of a line, oh, okay, Katlego, so if they say to you the line is y equals 2x plus 3, then they're telling you that the gradient is 2. If they say to you there is a line y equals minus 2x plus 3, then they're telling you that the gradient is minus 2. Okay, so if they tell you a line is a line y equals x minus 5, they are telling you that the gradient is 1. So remember, when we write a letter on its own in algebra, If there's not a number in front of it, it means that the number in front of it is 1. Okay, so now you know that the gradient of line AB is also 1. Okay, so now I'm going to help you. You are going to take that gradient. Let's just change colors here. Actually, it doesn't matter. You're going to take that gradient and you're going to substitute it into your new line. So your line AB, also has a gradient of 1. So y equals, and if you want to put the 1 there, you can. 1x plus c. Now you've got to sub in the point A. Minus 2 is the x, minus 4 is the y. Okay, so let's see if you can work out the c on your own. Okay, so Harry, you say that you agree. I'm just going to see if I can find something for you guys to do, because you're being, okay, I didn't put anything else there. All right, well, we should be able to finish this off and then go on to another one. I'm thinking maybe what I should do is give you the opportunity to practice one more before we actually go on to the next thing. Okay, so David and Katlejo and everybody else that's been so quiet tonight, did you manage to work out what to do here? So what we should have done, grade 10s, is in place of our y, we should have had minus 4. Oopsie, not a minus there, beg your pardon. So 1, and then in place of the x, we would have had minus 2. Okay, so that means that minus 4 is equal to minus 2 plus c. So that minus 2 has to go over to the other side. So it's going to become minus 4 plus 2, which is c, and that means that c has to be equal to negative 2. Is that what you said, Harry? Nizole, okay, there we go. Oh, good, Nizole, well done. Okay, good job. Very nice. Katlego, I'm not surprised you're struggling. It was a difficult lesson last week, and this is also still something that's pretty difficult for us to be able to do. Let's try one more. Okay, let's try one more, right, before we go and talk about perpendicular lines. Okay, I'm going to make one up here for you guys. I'll just move the chat out the way. Okay, let's do this. So I haven't given you a picture here. I've given this to you in words. All right. We want to determine the equation of a line. Let's call the line CD. And it passes through point K, and it is parallel to line y equals minus 2x plus 6. Okay, so Harry, you get started on that. Is there anybody else that would prefer me to go back to the y was c positive? Fine, Azole, let's go back to that. Okay, so Harry and everybody else that's managing, you go back to that, and the rest of us can talk about this question over here. AV. All right. So let me just look at the chat again 1 second. Wow, Harry, you're so quick. Why was C positive? Which C, Nzole? Which C did I say was positive? C was negative. C was negative 2. Did you get a positive 2? I thought you said negative 2 in your answer, Nzole. Yes, you did. You did say negative 2. I'm a little bit confused, Nzole. Which positive C are you referring to? Do you mean in the purple, Nzole? Oh, hang on a second. I think I understand what you mean. Nzole, are you talking about, that's what I thought you meant. Yes. Yes. So standard form, Nzole, is always y equals mx plus c. And the reason why it's always plus c at the end, okay, is because if you have a positive and another positive, it would end up being a positive C value. But if you had plus and you had a negative, then it would end up being a negative C value. So we just use plus as, how can I describe this? We have to use plus because plus times plus is plus, and plus times minus is minus. So in other words, when we want to work out the value of C, we don't want to change the sign around. That's why it's got to be a plus. Okay, so yes, this is standard form for a straight line. Okay, it is always y equals mx plus c. Okay, but if your C ends up being negative, then it would be negative C at the end. Does that make sense? I hope so.
Ma'am?
Yes, Maya.
From the previous equation where we said y is equal to x minus 5, does the negative 5 count, or is it just there? Do we like put it into account when we work out an equation?
So in this particular case, Maya, no, because what you will find here, okay, let me just go back. Harry says he's finished anyway, all right? Really good question, Maya, all right? What does this minus 5 represent in terms of the blue graph? It represents this point over here. Can you see where I'm coloring in, Maya? This is the y-intercept. Okay, so that over there is the y-intercept. Over here, can you see there? That is the y-intercept. So now, when a line is parallel to another one, okay, so these two lines are parallel to one another, is the y-intercept the same? So does the black line have the same y-intercept as the blue line, Maya?
No, ma'am.
No, it doesn't, exactly. So it has got a different y-intercept. So that's why the first thing that we do is we say, okay, the lines are parallel. That means their gradients are the same. So the gradient for the blue line is the same as the gradient for the black line. Then once we have worked out or established what the gradient is, then it means that we can sub in a point that lies on our new line to work out what this new y-intercept is going to be. Does that make sense? So
Yes, ma'am.
that minus 5 belonged to our old line. Okay, we've got to find out the y-intercept of our new line. In the same way, Maya, if you have a look over here in this question, okay, there are two lines in this question. There's the line y equals minus 2x plus 6. And then there's line CD. So there's two lines, right? What is the gradient of the line that's given?
Sorry, is it -2?
Good, Maya. Perfect. Okay. I'm sorry, maybe I didn't phrase that in 100% the right way. Okay, but this is the line that we've been given. Okay, this is the line that we're trying to calculate. Good, well done. And you were saying to me the gradient is -2. Excellent. Okay, what's the y-intercept?
6.
Good. Am I going to use the y-intercept when I work out the equation of CD?
No, ma'am.
No, you're not. Okay, you just want the gradient. Okay, so what are you going to do? You're going to take this over here and you're going to go and substitute it into y equals mx plus c. Okay, now we need to sub in k, the point -1 and -2. Oh, Nizole is asking, what's the difference between parallel and perpendicular? Nizole, good question. We'll work out C first, and then I'm going to talk about the difference between parallel and perpendicular. I'm really glad you asked that. Okay, so now let's see if we can get this right. All right, that is the x coordinate. That's the y coordinate. So in place of y over here, what do I need to write, grade 10s? In place of y, I'm going to write -2. Good. Equals -2. And in place of x, I'm going to write negative. Good, Harry. Okay, so that means that -2 is equal to -2 times -2 is +2. Right, and then when I take this 2 over to the other side, okay, it has to change its sign. So -2 minus another 2 is C, and that's why Harry got an answer of -4. Okay, I agree, Harry. That's what I would have got as well. So the equation of line CD, it takes the form y equals -2x minus 4. Okay, so is there anybody else besides Harry who managed to get that? Anyone else, grade 10s? Okay, Maya, you said you did too. Good, well done. Yeah, Nuzola did as well. Okay, Harry, thank you for pointing that out. That's cool, well done. Okay, this is difficult work. And if you've been able to do that, that's great. If you were just able to substitute in the -2, I'm still very pleased. Okay, so we haven't got a lot of time left. Time always seems to be our enemy, doesn't it? Let's just talk a little bit about, sorry, before I move on, is there, okay, David, perfect. Are there any questions, grade 10, or can I move on to what Nizole was asking me about the difference between parallel and perpendicular? Any questions? No? Okay, all right. I know that's where we were talking about it. Okay, so Nizole and everybody else, when we say that lines are parallel to one another, so if I draw line AB and I draw line CD, if AB is parallel to CD, it means that AB and CD will never meet. The reason for that is because the distance between them, this is what I'm drawing in purple now, always remains constant. So the distance between parallel lines never changes. So the distance between the lines is constant, so they can never ever meet one another. All right. And we indicate that lines are parallel in maths by drawing arrows on the line. Okay, and then this is how we would write it over here. So if I wanted to write AB parallel to CD, this is the form in which it would take. Okay, I'd write it like that, AB parallel to CD. When we talk about the word perpendicular, it's got a very different meaning. So if I've now, let me draw some new lines. So this is line HK, and let's draw it in a different color. There is line AB. So now grade 10s, if I say AB is perpendicular to HK, I use a different symbol, right? So these two lines next to one another like that is the symbol for parallel. But a sort of upside down capital T, that is the symbol for perpendicular. Okay, so the word perpendicular means, Nizole, that they cut one another at right angles. Okay, so where they cross over one another, it makes a 90-degree corner. Okay, so that's what this means. So perpendicular means they intersect at 90 degrees. Okay, in other words, at right angles to one another. Okay, have you heard the word perpendicular at school, grade 10s? Is it a word that your maths teacher has used with you? Yes, a lot. Okay, yes, yes. Okay, all right. So that's what it means. Okay, it means at right angles. So parallel means they run next to one another. They never ever touch because the distance between them remains constant. Lines that are perpendicular to each other means that they cross one another and it makes a 90-degree corner. So that's a really important word for us, not just now in grade 10, but all the way through to matric maths. Okay, so even in matric, you will be speaking about lines that are perpendicular to one another. All right, now this is the tricky bit. Okay, pleasure Nizole. All right, so what I'm going to do is just in our last 10 minutes, I'm going to show you something. I don't know whether you'll manage to be able to do this with the time that we have left over, but let me at least show you this and you can take it down as an example and you can see if you can maybe try and do it on your own. All right, so what I'm trying to show you in the diagram on the screen at the moment is line AB, and it is perpendicular to line CD. Okay, they've also given us a little bit more information. They've told us that the equation of line CD, the blue line, it is the line y equals minus 3x minus 1. Now that makes sense to us because we can see that we've got a negative gradient, the line is decreasing, and then they've told us the y-intercept is at -1. So we were expecting at -1, so we were expecting it to cross somewhere over here. All right, somewhere below the x-axis. So that makes sense to us. They've also told us that CD is perpendicular to AB. and they want us to work out the equation of AB. All right, so now the difference is this, and this is the tricky bit, okay? When lines are perpendicular, their gradients are not the same. Can you see that their gradients cannot be the same? I mean, this line CD has a negative gradient. Line AB slopes up to the right, so it has a positive gradient. Okay, so here the gradient is negative, okay, wherever we would measure it. On the pink line, the gradient is positive. It's an increasing line. Okay, so we can see that the sign has changed. And what has been discovered in maths is that when two lines cross one another at right angles, when we multiply their gradients together, we always get -1. Okay, so in other words, if line CD is perpendicular to line AB, it means that the gradient, so the letter M of line CD times the gradient of line AB will always be equal to -1. So this is something that you have to learn, and it's going to be something that you're going to use. Okay, so if we know what the gradient of CD is, we can substitute it in here. So the gradient of CD is -3. The gradient of AB is what we're trying to calculate. Right, this grade 10s is no different to you solving a simple, easy equation. All right, your gradient AB is like a letter. It's like an X or a Y or an A or whatever. So if I say to you -3x equals -1, how would you solve for X? What would you do to both sides of the equation? If we want to solve for X, what are you going to do to both sides of our equation? You're going to divide it by?
-3, divide the sides by -3.
Exactly, David. So you're going to divide the left-hand side by -3. Quite right, Ms. Ola. Divide the right-hand side by -3. So that means that X is going to be equal to positive. Remember, negative divided by negative is a positive, 1/3. It is exactly the same thing here. So this is just your unknown. It's like your X. Okay, divide both sides by -3, and that means that the gradient of AB is now going to be 1/3. Next step, you already know this, all right? I need a point that sits on the other line, okay? So I can see there, I've been given the point -6 and 0, which sits on the pink line. Okay, remember line CD is the line that I'm trying to find line AB is the line that I'm trying to find the equation of. So let's write in pink. Okay, we know that the equation of AB takes the form y equals m. We've just calculated the m, x plus c. I now want to sub in the point that lies on that line. It is the point -6 and 0. Okay, let's see if you guys can sub that point in and work out what C is. It's exactly the same thing as what we were doing before, exactly the same skills. The only thing that was different was the gradient, and we've done that together. So try and sub that in and see if you can work out a value for C. Cool, Harry, well done. Okay, so Harry says that C is 2. Nizole says she got C is equal to -2. Right, so both of you, if you didn't get it right, it's not the end of the world. Okay, so in place of Y, we would need to write what number? Mohamalepe, what number would I need to write in place of y? Nwazi, what would I write in place of y? Tim, you guys are so tired. Okay, Mohamalepe. Okay, so in place of y, I would need to write 0. This is my x. This is my y. Okay, so y is 0. 1 over 3, x is equal to -6. So that means that 0 is equal to 1 over 3 times -6 is going to leave me with -2. Okay, and maybe that's where you got the -2 from, Nizole. It is indeed. Okay, so that -2 has got to go over to the other side and become 2. There we go. So that means that the equation of this line, it's going to be the line y equals 1 over 3 x. That's fine, Nizole. Don't stress. I make mistakes all the time. Okay, nothing wrong with that. We're all here together to learn. Okay, so y equals 1 over 3x plus 2. Sure, I can't believe our time is actually up. But anyway, are there any questions, grade 10s? Is there anything that you want me to explain? Are you sure there's nothing you want me to explain, grade 10s? There's no questions? Nobody wants me to go back over anything? Are you sure?
Ma'am,
Maya?
could you please re-explain the -1 over -3, -3x? I got lost today.
That's fine. So Maya, did you get lost in the concept, or did you get lost in why the negative times a negative becomes a positive?
I think I got lost in the concept.
Okay, all right. So Maya, this is something that we have to learn, unfortunately, all right? So what people have discovered, people have done lots and lots and lots of experiments, all right, to work out things that are true. And what they've worked out is that when lines are perpendicular, so in this case, line CD is perpendicular to line AB. What that means for us is that when you take the gradient of line CD and you times it by the gradient of line AB, you always end up with -1 as an answer. So that is like a mathematical fact. Okay, that's always true, like gravity. Okay, gravity always applies. There's never a day that we get up in the morning and we're floating above our beds. Okay, there's always gravity. So in the same way, if you've got two lines and they meet at right angles, when you multiply their gradients, you're always going to end up with -1 as an answer. So we can use that, Maya. We can make an equation out of that. So in other words, what I'm writing here is I am saying gradient of CD times gradient of AB is -1. There's my equation. If I then know what the gradient of CD is, I can substitute. So now I'm substituting gradient of CD as -3 times the gradient of AB is -1. And then what I was trying to explain, Maya, is that you can look at this gradient of AB. It's just an unknown, like it's an X. It's no different to if I say to you, Maya, I want you to solve the equation minus 3x is equal to minus 1. Solve for x. It's exactly the same thing. This gradient AB and the x function as our unknown. So just like you would divide both sides here by -3, so you're going to divide both sides here by -3. Okay, just like this -3 and that -3 would cancel out, and you'd get x is equal to negative divided by negative is a positive 1/3. Same thing happens here. -3 divided by -3 is positive 1. So positive 1 times AB is gradient of AB. Negative divided by negative is a positive. Okay, that's what I was getting at. Right. Nizole, it's a pleasure, Maya. I hope that makes a little bit more sense to you. And then how you would work out C is exactly the same as for a parallel line. You're now going to take the gradient, substitute it in, sub in the new point X and Y, and work out the C value. Okay. Pleasure, David. No problem. No problem. Okay, so Tula,
Yes.
Nizole just says, ma'am, can you show the questions we haven't done so we can check them later? Would that be so that she can look at them on the video?
Yes. So if
Okay.
you just put them on video, they'll be able, I think, to access them on the recording.
All right, so there we go. So I'm just going to expose those answers like that, and then you can try those questions, okay, Nizole? So that would have been the one that I would have given you for your turn. And then let's just go down here to the exit ticket. All right, and then those answers are exposed as well, and then hopefully you can try those on your own. Okay. Sorry, I've gone a little bit over grade 10s. You must all be feeling frazzled and fried. But that's the end of our lesson for today. Okay, I hope everybody's all right. Thanks, Tula.
Yeah, I'm also actually curious, how's everybody feeling? Not just about today's lesson, but just how's your week going in school in maths? You can unmute yourself, you can type. We just want to know how you guys doing. Katleho's feeling okay. I'm glad to hear that, Katleho. How's everyone else feeling? Shame, man. Everyone's tired. Very understandable. Nizole is asking if you can show the last equation.
Nizole, do you mean the blue one? Is that the right one? Am I in the right place? Yeah, shame. Everybody just seems to be exhausted. Hey, Tula.
Yeah, I think we should let everybody go at this point so they can get some rest.
Yeah.
We have the lesson on Thursday for exam revision. I don't think you'll be here, Lee. Do you want to
No,
say
unfortunately
your
not.
goodbyes?
No.
Yes.
Okay, so yeah, there's going to be another gentleman who's going to be teaching you. I'm just going back here for you, Nizole. I think this is what you wanted. So yes, he will be doing the last lesson, which is based on exam type questions. So I wish you all the best of luck with that. And then I'm sure I'll see you all again next term.